Hi guys, this video is one of the first introductory videos to FXGL. It is a gaming library in JavaFX that I've been writing for a while, and it will help you to develop your small to medium-sized games. It will hide most of the boilerplate and the code that we write, so the repetitive part of the code. And on top of that, it will give you certain features like resource loading, resource saving, collision detection, and stuff like that. So there will be a link in the video description that will send you to that page. This is where you can download the latest packaged version of the library. So if you click on 004, which is the version we'll be using in this video, there might be newer versions there, but I would recommend sticking to the version in the video, and this applies for future videos as well, because the development is very early stage, so API might change from one version to another, and there is no guarantee that newer version will work with the same code that you used in the older version. So if you click on 004, it will send you to a new page. And this is where you can download it. Click on the raw button. It will prompt you with the download dialog. Once you've saved that, you will have a jar file, which is packaged library plus the source code of the library. And then we'll do the setup. So basically this video is all about setup, making sure everything's working, and basic introductory stuff like what things you can do in the library or with the library. There isn't a demo to show you at this stage, so I'll just code as we go along. So create new project or use your tutorials project if you have that still. So right click on that, you create a folder, name it lib, so lib. This is where the libraries will be stored for your project, and either copy and paste or simply drag it over to that folder. Now we have a directory called lib with FXGL library inside. Now we need to point our project to use that library. So right click on tutorial or project name, and then go to Java build path, the libraries tab, and add jar. Navigate to your FXGL library, click OK, and it can now have access to it and use it. So now we should be able to create a new package. Com dot your nickname, then dot name of this tutorial, which is 18, I think. Yep. Now I'm going to create the main class, which is essentially FX demo app or something. I'd also like to address the issue some people are having with smaller screens. The text was very difficult to read, so I'm going to do go to preferences and set the font to 12 or 14. Yeah, that should do it. If you did have this problem, could you post a comment or provide some feedback whether it is more readable. Alright, so now we have a class called FXDemoApp, which extends game application as opposed to JavaFX application. Now, since we linked the library, Eclipse should already say or should find it and say that you must import before using it. Then it will prompt you to add unimplemented methods. These are the methods that are supplied by game application and that you need to implement in your own class, so in your own application class. We'll go through them in a second. First of all, let's create our entry point. And in our entry point, we'll simply launch the application as we always do with the JavaFX application. So nothing is different in there. And if we run this, it should already run. So it runs and has nothing in it. So it's just a simple window with a title saying Untitled FXGL game application and the version of the your application. When you run applications based on FXGL library, it will first of all print the version of the library, so make sure it's 0.04 for this video anyway. You can get latest builds and source code of the library following this link, which will be which is basically the one that you use to download the library itself. Okay, so what we have now is so we have overridden several methods, and we'll just go through them. Init settings initializes settings for your game, but mainly for now is just a window really. So you can use this settings object to set certain things. You can set width of your window, or rather width of your container of the window. So if we say 1280 and settings, set height 720, so 720p window. So the width that you set here is the width of the actual pixels, not the window. Window is slightly larger because of the borders and the window frame. And you can also set title, settings, set title, FXDemoApp. And the last thing you can do, set version, which is 0.1. And this will be reflected on the name of the window. Now, init game is where you initialize the game objects, add collision handlers, initialize input, so add like input bindings, key bindings. And we're gonna do just that. Yeah. So if you want to create a game object within this library, any game object like a player, an enemy, NPC, a coin, a weapon, a piece of armor, so basically anything is an entity. First of all, you need to import class entity. Make sure that you import the right version, which is com.lmsb.fxgl entity. And we'll name it player. So an entity takes a single parameter, which is of type string, and this is the type of your entity. And our type is player. So if it was an item, your type would be an item or weapon or enemy. This is used to distinguish entities between or among each other. Next thing you want to do is set position. So as you can see, all of these methods really come from the node class because entity at some point extends it. So this FXGL is basically a gaming library which is built on top of JavaFX and acts like a bridge between your game and JavaFX. Player set translate x 50 and the y 50. Now that we've created our player, it still doesn't have any sort of visual thing associated with it, which we'll do in a second. First, the thing that you want to do after you've created your entities is add them to the root node, which you can do by calling a method add entities. Also, if you would like to check out all of the methods that are available to you, just click or type this dot and Eclipse will give you all the things you can run, all the methods you have access to from game application class, and also some of the protected fields. So yeah, add entities player. This will add it to the root node or to the game root. So you can add it either directly or using this method, which is better because it does its own internal synchronization so that the threads don't interrupt each other. So yeah, if you want to display an entity, you must add it to a list of entities using this method. Currently, we haven't set any graphics to that, so when we run this, we should see just null, which is signifying that you haven't associated this particular entity with any graphics or any visual. So what we're going to do is create a rectangle with width and height 40, so basically a square. And then we're going to associate this square with the player set graphics. So entity.setGraphics will associate a particular visual node with this entity. So now instead of null, it should have a square, and it does. Now we want also to be able to control the player, or using keyboard. So what we'll do is put it up here so we have access to it. Now you can do key bindings using, again, this add key press binding or key typed binding. The difference between them is key press is a constant call, so repeated key actions will be executed. Key typed will be only executed once per single physical click or key press. So this add key press binding, so key code. This is the key that you want to bind to, and we're going to do the W for, this is a runnable, so we're going to use lambda, and anything in between is the code that will run once the W key is pressed. Player translate, translate is the method they use to move entities around. W starts going up -5. We're going to do this 3 more times for S, A, and D. So S will move it south, A will move it to the left, -5, and 5. So if we run this now, we have WASD control over the player entity. We can also have another entity, so enemy. The type that we're supplying is enemy. This string is, because it's not being type checked, the best thing is to use constants, so like private static final string type player, and then do this, and do that here, so that you can check that you haven't made a mistake or a typo when typing out the characters. This way you can ensure that nothing, so wherever you type something, it will be exactly like this, because you cannot, your compiler cannot check whether you typed the word enemy correctly. And if you have type enemy here and then slightly different version of an enemy, they won't be matched, and that could be a problem, especially if your application is large. So we'll do this again for the enemy as well. So instead of you looking out for all these things, the compiler will do it for you, which is nice. So add entities takes arbitrary amount of parameters, so you can just do this instead of typing add entities again. Now we're going to position our entity, enemy entity, translate x 400. Translate y 50, so they will be on the same line, and we're going to specify the graphics for it slightly bigger. We're going to say change color to say red. And we set graphics. So now we should have two entities up. We have our player, which we can control, and we have our entity enemy. Now, one of the things I like to do is collision detection. So in order for two entities to perform collision detection, you first of all set use physics to true on each entity that you want to be able to collide or participate in collision detection. There aren't any actual physics right now involved. It is basically a collision detection flag. However, in future versions, I'm planning to add JBox integration to FXGL, so there will be real physics simulation. Now we've added set use physics flag to set it to true to player and enemy, and after that we do collision handler registration collision handler, so which is done using this add collision handler. Type A is player, or we now have a reference to string, so we're going to do this type player and type enemy, and this is the collision handler. which supports functional interface. So we're going to use lambda. It takes a player and takes an enemy. So now the types that you specify here, type player and type enemy, in this particular order will be called in the same order when you get the callback. So if you specify type enemy here and type player here, you'd have to change those things. So it would be E, comma, PL. So PL stands for player, E for enemy. I just didn't want to use the same because it'll complain. So yeah, whenever a collision occurs between these two types, those objects that collided or participated in collision will be passed to you, so you can do something with them. Let's say, so yeah, if player and enemy collides, enemy will move down, so 300, just to check that it works. So when we collide with the enemy, it'll move down, and as you can see, it's the right object that is being passed. So player, and this one's player, type enemy, and this is the enemy object that it will be passed to you. And this is how basic collision detection or collision handling is done. So if you have like bullets and enemies, you might have type bullet, type enemy collision detection, collision handling, and then set, oh yeah, another thing, you can set properties in order to make or add a custom field to your entity. So say our enemy could have set property. This is the name of the property. Again, I don't really like strings being typed literally, so you could do another constant string saying property alive and then put that instead. But since it is a very small application, I'm going to keep this string here. Set property to true. So the object type that you can set here as a value is basically any object or any type, which is really useful because you could use integers, doubles, so basically any type you want. And you can also get it back using entity get property and then the name of the property. Make sure it is exactly the same name, otherwise it won't return, will return null. So this is how you can set custom properties to your entities. We're gonna keep this thing here, and when we hit the enemy, we're going to set property alive to false, and then we'll check it on update. But first we'll just quickly cover init UI. This is basically where you initialize your UI stuff, user interface. UI root is the root node for user interface or the viewport that you can see in your game. So just do a quick thing saying take score text, import that, text score, set translate, again you position it where you want it to be, set translate y. And then once you've created your node, you add it to the children of UI. So this is your UI stuff that is being displayed, the text score that we've just created. Okay, back to our enemy. So our enemy now has a property alive, and it is set to true. When a collision occurs, it will be set to false, and once it's been set to false, we can check an update and clear it, or remove it from the root node so it is no longer displayed. You can do this with bullets and enemies, and bullets and I suppose bullets as well. So like when two bullets collide, they both disappear. This onUpdate method is called 60 times a second. So this is basically your typical update tick in a game loop. And what you can do is get entity. We're going to use this. This get entities. As you can see, it takes an ellipsis of types, and you can do. We have type enemy. So this will return a list of all entities whose type is enemy. Now we can obtain stream to it, and this is a JavaFX 8 stuff, so which introduced Java 8 stuff, sorry. They introduced streams, so you can do this either way. I'm going to do a stream one and basic JDK 7 one, so you can see both of the versions. Stream, filter, entity get property alive. So if it's not alive, and for each remove entity. This is basically a more functional way of doing stuff, more fancy way, I suppose. The old way is, so you can obtain a list and do a for loop. So for entity E in list of entities, so this returns a list of entities. Then you go through each entity in that list, but we still we just have one entity. But this will work for many entities if you have more than just one. Then you check if E get property alive. So basically, if not alive, if you don't use the boolean, because it could return an object of any type, it doesn't know what type it is returning. So you can specify this just typing that after a dot, saying we want the boolean property. So if it is not alive, then we remove the entity. And this is how you remove an entity from the game or from being visible. So these two things are equal in the meaning, but as you can see, the syntax is different. So I'll just comment it out. So this thing runs all the time and checks whether it's alive or not, this particular object, because we are getting entities of type enemy. So when we collide with it, it should call this, which will set property alive to false, and on the next update tick, that should remove the entity. Yep, there we go. And you can do this with bullets and enemies, or with any type of projectile. And I think this is all for this particular tutorial. we'll go over resource loading in the next tutorial. So basically all textures, audio, music, and stuff like that. This FXGL library is primarily aimed at beginners in JavaFX and possibly intermediate programmers. So you should be able to build medium-sized games or up to medium-sized games. And yeah, the more people interested in this project, the more I'll be inclined to continue development of it and maintain it. So yeah, leave your feedback about the library and what other things you'd like to see in future versions of the library. And thanks for watching.